So today, look over the sideboard, geometry, like the Acorn said when he grew up, geometry, okay? Thursday, the 5th, SWPA students will be able to, I say the T is silent jokingly, classify and use angle pair relationships, section 1.5, okay? So we talked about measuring angles last time on True or Tie Tuesday. Now we're talking about different relationships going through them, okay? And we're talking about pairs as well. A pair is how many? Two, okay, dos, okay? So a pair is two angles, okay? We're talking about different relationships between two angles in this section. Now before we dive into that, okay, we're going to talk about an angle bisector. Guess what? We're going to have to do homework class, hopefully. Or not all of it, but hopefully start. Okay? An angle bisector. You guys remember segment bisector? What does a segment bisector do?
It splits
A segment bisector, Grace.
It's a point between all the.
Okay. Not a segment bisector. What was a segment bisector, Emily? Okay. So it's the middle of a segment. Okay. It cuts the segment in.
I said that.
I heard angle in there somewhere.
Between all the, I said it. Between all the points, like where all the points meet up.
It's after 1.4, the very bottom. So you need to flip one more page over there, the very bottom. There you go. Okay. So a segment bisector was anything that cut a segment in half. It cut a segment in half into two congruent parts. An angle bisector will be similar. It's going to cut an angle in half. Okay. So it's a ray. It has to be a ray that. Yep, I have water over there. Okay. That divides. The word is divides an angle into two congruent angles, okay? 1.5 is right below the end of 1.4 there, okay, by the way. Okay? An angle bisector is a ray that divides an angle into two congruent angles, okay? Into two congruent angles. And you guys remember last time we had these arcs here. These are drawn as lines right now. I'm going to fix that, make those arcs, okay? We have these arcs here that denote that these are congruent. So right here in this case, ray AB is the angle bisector. So therefore, what two angles are congruent? Angle what, and angle what?
ABB.
Okay? Be careful. I agree with your second one, okay? DAB, angle DAB, okay? Your first one, though, needs a little bit of rearrangement. What point do we have to have in the middle?
I said CAB.
Okay, maybe I misheard you. Okay? Angle CAB is congruent to angle DAB. I would agree with that, okay? And I love using it as DAB because it's dab, okay? Could we also order it BAD if you wanted to?
Yes.
Sure, as long as that A's in the middle, okay? That's what matters, okay? But I like dab, okay? Yes, it is a bit of a weird flex on the deal, okay? Just like my dab push-ups, okay?
Well, we haven't seen them. Let's see it.
You haven't seen them?
I don't believe it.
Yeah, let me show you some of the difference.
Yeah,
I don't believe it if I haven't seen it.
You might have not mentioned
Were you here that day?
I don't
No.
think you
Oh,
was.
okay. I'll do it one more time. Okay. Using an angle bisector to find the measure of several different angles. Okay. So up here, the measure of angle CAB would be equal to the measure of what other angle? Angle.
BAC.
Okay. Measure of angle CAB. It's the same angle as that, so that we want to say a different angle. So what's the different angle? DAB.
I said BAB actually.
Oh, oof.
It's
Okay. So, what two angles can we add together to get the measure of angle CAD, this whole thing?
huh?
Why? What two angles can we add together to get the measure of the whole thing CAD? Okay, what two angles do you see inside of this angle? Okay, angle CAB. That angle plus what angle will give us the full thing? Very good. BAD. Thank you. Okay? We'll end up equaling the whole thing, okay? So here's the thing. If each of these is half, if each of these are half of the whole thing here, okay? Each of these are half of the whole thing, then could we double one of this to get the whole thing? If something's half, can you double it to get the whole? Yeah. So you can say 2 times the measure of angle CAB will equal the measure of angle CAD, the whole thing. Or you can say 2 times the angle of the other side DAB, BAD, whichever one you want to call it, will equal the whole thing as well. We're saying you take 2 times either of the angles, either of the halves, to get the whole. Okay. So let's go ahead and flip the page there. Sorry for all these obnoxious colors, and that's something I actually need to change, go back and fix at some point.
Oh
I know.
my god.
I know, it's pretty extreme.
You're gonna drive every city person crazy.
Probably. Okay.
I can't even look at it without like it really hurting my soul.
Sorry, yeah, I know. I see a lot of action. I know. It's I'll be honest, it's bad. Okay.
I mean, if it was.
I'm working on a different example for next year. Calm down.
Red
Okay,
and
maybe
green,
if it like
Christmas.
actually coordinated, like one sees yellow, the
I
one
know.
sees
I know.
red.
I know. It's bad.
Christmas color.
It's pretty terrible. Okay. Anyway, so ray AB, this ray bisects the angle CAD. What's it mean to bisect? It cuts it in half. Okay. So that means that this half is congruent to what? The other half. Okay. These two angles are congruent to each other. We're also told that angle CAB is equal to 2x plus 10. Voices off, guys. Is equal to 2x plus 10. And the angle BAD is equal to 3x minus 20. Okay? And then we're told solve for x and find the measure of angle CAD being the whole thing. Okay? How could we solve for x here? Solve for x, so our mind should be on setting up an equation. And Colton's saying setting them what? Equal to each other. Okay? Whenever we hear congruent, some alarms, cowbells, buzzers, whatever, should be going off our head saying, set them equal, okay? If they're the same measure, then we set them equal. If 2 things are congruent, we're going to be setting them equal. For solving for x, we need to make an equation. If they're congruent, we're going to set them equal in that equation. How would we solve this equation? What would be our first step, Sam? Okay, subtract from 10x. 3x. Subtract 3x, okay, good. 2x minus 3x is negative x. This doesn't have to be how you do it, but we could. 3x minus itself is 0, and negative 20. So if we have all the x's on the left side, what do we want to move? Where do we want to move the 10 to? The other side. How do we move a positive 10? Negative 10, very good. Negative x is equal to negative 30, okay? So hey, negative x, we want a positive x. How do we get rid of a negative x? You divide by a number, divide by a negative 1 on both sides, okay? You can think of it as there's really a negative 1 times that, so we can divide by that negative 1 being multiplied there, okay? Negative 1 divided by negative 1, we're just left with x. A negative divided by a negative is a positive. So we found x to equal 30.
Why didn't you just do the easy way?
You could have. Algebra is a lot of different ways.
Making that a negative, couldn't you just do negative minus 2?
Yep, you could have.
Okay, why didn't you do
Could've.
that?
Because that's not the step I was given. I
Way to go,
asked,
Sam. It's all
hey
good.
Ian, where's your notes at, buddy? Okay. I'm out of copies right now, so why don't you take a piece of paper? It's alright. So,
Do you need
now,
a piece of paper?
Alright, no. Okay. Okay, hey, next time, don't just sit there and not do anything. Let me know. Okay? So I'll actually provide a solution. Okay, you're not helping yourself out very much here. I can't help you if you don't help yourself. Okay? So we found x equal 30. We're also asked to find the measure of angle CAD, this whole thing, okay? Does anyone have any ideas on how we can find the measure of angle CAD?
Add them.
Add them, add what?
Plug in 30 for x, and then
Into which
add
x?
both.
Both, okay, and then add them together?
Yeah.
Okay, cool beans, let's try that, okay? So 2 times 30 plus 10. 2 times 30 is 60, plus 10, 70. Try this one. 3 times 30 minus 20.
Are we plugging these in?
Yep, we're plugging it into both of them right now. That's what
Okay.
Grace suggested there, okay? 3 times 30 is 90, like Grace said. Minus 20, 70. Hey, what do we notice about these two?
They're congruent.
They're congruent. They're the same measure. Should they have been the same?
Yes.
That's good. If they weren't the same, did we do something wrong?
Yes.
Yeah, we should have fixed it, okay? Now what do we do with the 70 and the 70?
Add them.
Add them together, we get
140.
140, okay? And that is the measure of angle CAD, like we were supposed to find the whole thing.
You're asked to find x and the measured angle CAD. You did just that. Okay. Now, hey, could you have plugged 30 into just one of these and then doubled it? Yeah, but would you have been able to check your work along the way? No. Okay. So that's a risk you take. Okay. You can choose not to double check your work, but I would advise to double check your work because right there, test taking tip, you know instantly on the test whether you got it right or wrong. And then if you got it wrong, you can go back and fix it if you still have time. Okay. Seems smarter to me. Okay. Any questions on this left side? On up here, left side of the tube. Okay.
Yeah.
Let's go over to the right side of this, the right side of the line there. Okay, so we're given the same setup here a bit, okay? We're given a bit of the same setup. We're given that ray AB bisects CAD, meaning it cuts it in half, very good. So that means this angle and this angle are to your right, angle 1 and angle 2 are to your right, angle CAB, angle BAD are to your right. We're still asked to solve for x and the measured angle CAD. What's different, okay? What's different is that we're told that the measure of angle CAB is equal to x plus 5.
Come on here.
You wanna knock that down?
Do what?
Okay. Measure of angle I was talking to you.
Oh.
Measure of angle CAB is equal to x plus 5. So let's mark that in. Mark what we know. Okay. Measure of angle CAD is equal to 4x minus 12. That's the whole thing. So that's the every notes. And you want to get those out. Okay. You want to do that now, please. Okay. So we're told the whole thing here is 4x minus 12. Okay. We're told the whole thing is 4x minus 12 this time.
But like CAD is.
Yeah, we're told the whole, and let me mark that a different color to make that more obvious actually. Maybe that's a little unclear to us in that color. Let me mark that a different color to make that a little more obvious.
Can you put it under so like we don't think it's BAD equals what? Is that what we're trying to find?
Like that, Grace?
Yes.
Okay, so I'm saying this whole angle here is 4x minus 12. Okay? This part right here is x plus 5.
Good problem.
Does anyone have any ideas on how we can do this? No one, what are you thinking?
It's not gonna equal out right,
Why not?
because it's 5 plus 12 is 17, and then when you subtract x from 3x, or when you subtract x from 4x, it makes it 3x.
Okay.
And then
So what
this-
kind of, so did you do this problem, Nolan? Did you do x plus 5 is equal to 4x minus 12?
Yeah.
Can anyone tell me why that would not work?
Well, because we're not trying to like if you add them together, we're not trying to find the like full number. We're trying to find partial.
We're trying to find partial, because this is how much of this?
That's half of them.
That's half of it, right? Okay, so they can't be equal to half. 50 cents is not equal to $1. What do you have to do to 50 cents to make it equal to $1?
You have to add the other part.
You have to add the other part, you have to add another 50 cents, you have to double it, right? If this is x plus 5, what is this also? X plus 5, okay? Now could we do x plus 5 plus x plus 5 is equal 4x minus 12?
That's wrong. I checked it.
See how we got that there, okay? Okay, so do you understand how we got this extra x plus 5 there? Okay, so we're saying that these two angles are congruent, right? Okay, so that means they have the same measure, right? So if this one's measure is x plus 5, what's this one have to be? X plus 5, okay? Now in the previous problem, we said that we could add these two together and get that. Does it make sense now? So, thank you.
Which, now can we do the whole minus 2?
So now we can look to start solving, okay? We first want to say, okay, hey, on this left side of the equation, do we have like terms we can combine?
2x.
Okay.
And
Okay, x plus x is 2x, and 5 plus 5 is 10. Very good, okay? Remember, when we're on the same side of the equal sign, we're on the left side of the equal sign, same side, do the same signs as what's there. When you're on the same side of the equal sign, do the same sign as what is there. So we make this positive, positive, we add them together, okay? But now, as we move across the equal sign in our next step, we're going to do the different sign, okay? So what would we move across here?
minus 2x.
Okay, let's subtract 2x for both sides. I think that's a good math move, okay? 2x minus itself is 0. So you have 10 is equal to 4x minus 2x, which is 2x minus 12, okay? Wyatt, what would you do next?
You would
Add
add 12.
12. Okay, let's add 12. Okay, so 10 plus 12 is 22. that's equal to 2x, okay? There's one step left, okay?
X equals 11.
Okay, whoa. Hold your horses. Find some horses. Maybe look in the back, okay? Hold them, okay? So, hey, Skylar, 2 times x, how do we undo multiplication?
Dividing.
Okay, we divide, okay? What number are we going to divide by?
2.
2, very good. So then, what's 22 divided by 2? 11. So x is equal to 11 here, okay? Now, we were asked to find x, and what else are we asked to find, okay? Jessica, what else are we asked to find? CAD, okay? How could we find CAD if we know x is equal to 11? Who can help us out there? Put 11 in for x here? Down here? Yeah, because that's what's equal to CAD, right? Okay, so let's put it in here, okay? I agree. So we have 4 times 11 minus 12. We're trying to find CAD, so let's plug it into CAD. 4 times 11 is 44. What's 44 minus 12? 32. We're told that the measure of angle CAD is equal to 32 degrees. Okay, equal to 32 degrees there. Now, could we also plug in the 11 to here and to here?
You could.
Yeah, you could have, right? That'd be like what we did last time, okay? You'd say, hey, like 11 plus 5, oh, that's 16. 11 plus 5, oh, that's 16 again. 16 plus 16 is 32. So we can check our work that way. You don't have to, you could, okay? I like Jessica's way of going down here and plugging that in. But if you wanted to check the work, feel free to do that as well. It's an awesome idea. Okay. Any questions on those 2 examples? Anybody still need those 2 examples before I move right below this? Okay. Okay. Hey, now we're going to talk about adjacent angles. Does anyone know what the word adjacent means just in general? Okay, Marissa? Means they're next to each other, right? Okay. So for example, Nolan and Taylor are adjacent right now on their desk, okay? But Jessica and Brayden are not because Cole's between them, okay? So adjacent means there's next to with nothing between them, okay? So for adjacent angles, they're gonna have a common or shared side. They're gonna have a common or shared side. So if every angle has 2 sides, we're just gonna say they're gonna have one of those sides shared or in common. And they're also gonna have a common vertex, okay? So every angle has exactly 1 vertex, and they're gonna share that vertex, okay? The endpoints of these rays. So here for these 2 angles, okay, if I call this point C, if I add in that point C down here on the vertex, and I add in this point W, what would be our common side between these 2 angles? Ray what? Ray CW. Ray CW is shared by this angle on the left and this angle on the right, okay? And what is the vertex that both of them have? Yeah, point C there, okay? So notice these 2 angles are adjacent because not only do they have a common side, they also have a common vertex. They have the same side and same vertex.
Why do you put the W there?
So that way we can name the ray.
Why do you use W?
Just
That
because.
is the letter. Okay.
Yep, we could have picked any letter for either of these. That's a good question, guys. We could have picked any letter for these 2. I just picked some random letters, okay? Could have picked Q, could have picked R, could have been whatever. Could have been R.A. for Rick Astley. Could have picked Rick Astley. Rick roll people.
Who's
Yeah.
that?
Never gonna give you up? Never gonna let you down?
No.
Never gonna run around and desert you? A song? You've never heard this.
He's heard the song.
No, I don't. I've literally never
Okay.
heard this.
Going right below this, we're gonna talk about vertical angles, okay? We're gonna talk about some different angle pair relationships. Now we're talking about vertical angles, okay? Vertical angles, these first 3 are gonna be qualifications, and the 4th one is always gonna be true if it meets those first 3, okay? So the first one is they share a vertex. So 2 vertical angles will always share a vertex, okay? So just like adjacent angles will always share a vertex, okay? Their sides make 2 straight lines. Their sides make 2 straight lines. Or I also like to say, in parentheses up here, kind of a slang term, so to speak, is that their sides make an X. Their sides make an X, okay? Kind of some slang there. I think it's a helpful way for us to remember it. I'll explain this in a minute. And they're always across from each other, okay? If they're across from each other, are they going to be next to each other? Are they going to be across and next to at the same time? No. If somebody's across the room from you, are they next to you? No, okay? Sam's across the room from me. He's not next to me, okay? Colton is more next to me, okay? He's not across the room from me. Colton's next to me, okay? But Sam is across the room from me. Okay, so these are not adjacent. Okay, these are not adjacent. Okay, and they are always, always, always. What's that symbol mean? They're congruent, equal in measure. They are always, always, always congruent. Okay.
Wait, so like you would say 46 and 46 are.
Okay.
What would you say?
So we could say that these two right angles, the left and the right, that are both 46 degrees, those are a pair of vertical angles. You say these two angles are a pair of vertical
You
angles.
said they're adjacent.
Okay, they're not adjacent.
Why though? Because they're
Are they're not next to each other.
but they're touching.
But do they have the same vertex? Do they have one of the same sides?
No.
No, so they're not adjacent.
Oh yeah, that's right.
Okay, so they have the same vertex. They share a vertex. That vertex is point E. If we look at their sides, here, okay, the side of this angle and this angle, side of this angle and this angle, that makes a straight line. Okay, if I cover that up with a line, it makes a straight line. This also makes a straight line. If we look at that there, what's that make? It makes an X. Okay, it makes an X. And now it's not like it goes like this. Okay, and like this angle and this angle, okay, this side doesn't make a straight line, even though this does, okay? So because this doesn't make an actual even X, whereas this makes a more even X, that works out there, okay? Okay? And they're across from each other, so they're not next to each other. They're opposite of each other. They're on opposite sides of each other, okay? And so they are always congruent. They're both 46 degrees, okay? So in addition to the two red ones here, what's another pair of vertical angles here? The two purple ones there, okay? Kind of like a periwinkle color there, okay? Those are going to be vertical angles as well. Yes, Emily? They have to make a perfect X to be vertical angles, yes. It's a good question, yeah. They have to make a perfect X to be vertical angles, okay? So they have to share that vertex, have the same exact vertex. They have to make a perfect X, is a good way to think about it. And they're always going to be across from each other, okay? They're always going to be across from each other. Okay.
On to the next one.
On to the next one, okay? On to the next page here.
Are we gonna say?
So, on example 25 here, okay? Example 25 here is what Mark does. Find X. Well, okay, here we have an intersection. We're not given any actual measures besides that this angle is 3x plus 20 and this x is 10x minus 15. We're not given like these two angles. Add up to this. We're not told anything specific about them. What kind of angles are these though that we just learned? Vertical angles. Do they share the vertex? Okay. Are they? Do their sides make an X? Yeah, it makes a perfect X, and they're two straight lines. Straight line, okay? And are they across from each other? Yeah, they're across from each other on different sides, okay? And so that means that these two angles are always congruent. So we can mark them congruent. And if they're congruent, we should have alarms, cowbells, bells and whistles telling us to do what? Set them equal to each other. Set them equal to each other. So if we're finding X, we need an equation. If they're congruent, we should have everything in our mind telling us to set them equal to each other, okay? Peyton, you want to give me the equation for this? 3x plus 20 equals 10x minus 15, okay? So we have one angle equals the other angle. One angle, I said angle there. One angle equals the other angle, okay? Let's write down after, let's forget. Okay? From here, could we go on and solve for x? If you solve for x, could we also go back in and plug it in?
Yes.
Okay, I'm going to move on from that from now, though. Okay, I'm going to trust that we can solve that for x using our algebra skills. Okay.
I finished it already.
Good for you. You got extra practice.
Yeah.
Okay. We're going to talk about a linear pair of angles. Linear pair. What's linear? What word do we see with linear there? Line. Okay. Pair means two. Okay. So a pair of angles that make a line. Okay. So for them to be a linear pair, they have to be adjacent, which we said earlier, but they're next to each other. And they must be what we call supplementary. Okay, they must be what we call supplementary. That's a new word for us.
Wait, so that means they have to equal 180?
That doesn't mean they have to equal 180 degrees. Okay? Supplementary, which means they have to add up to 180 degrees there. line, if it adds up to a straight line, we know the measure of a line is 180 degrees, right? Okay? So if it adds up to 180 there, okay, it's adding up to a straight line. So that's how we can kind of remember that word, linear pair, a pair that adds up to 180 and they make a line. Okay? Now, let me run through another kind of a side example. You guys don't have to write this part down at all. Okay? So if I have this angle here, and I say, oh, this angle's about 60 degrees or so, okay? And I have this angle here, 120 degrees. Do those two add up to 180? Yeah, they would. Mason's saying yeah, okay. They add up to 180, so they're supplementary, but are these angles adjacent? No, they're not next to each other at all. They don't share a vertex. They don't share a side. So even though they're supplementary and they add up to 180, they are not a linear pair. Because together, do these two make a straight line that we see? No, we don't see a straight line at all. We see two entirely separate angles, not even touching. Okay? So it's not a linear pair, even though it's supplementary. Whereas right down here, we see these two angles. Do they make a straight line together? Do they share a vertex and a side? So are these two a linear pair? Yeah, they would be a linear pair. Are they right, Mackenzie? Yeah, they would be a linear pair, okay? Hey, so if we have these two being a linear pair, we know they add up to what measure? 180, okay? So who can give me an equation here? Kale, can you give me an equation we could use with these two if we were to find x? Exactly right. I couldn't agree with you more, okay? 8x minus 16 plus 5x plus 1 equals 180, okay? We said, hey, if they add up to 180, we're literally going to add them up to 180, okay? We're going to add it instead of equal to 180, okay? Simple as that. Okay, I like to think that's pretty straightforward. If we're going to add up to 180, we're going to add to 180. Mm-hmm. Questions on the setup of that?
Wait, so
Yes.
when you, so the end thing, what would it say?
What end thing?
Like the end.
Like
Because I'm
the
kind of
end?
confused.
If we were to
Because I
solve
thought-
this equation,
Yeah, because I thought that the other side would like add up to being one. So would it just be 180 equals 180?
so these all would end up equaling 180, okay? So if we found x from this equation, okay, we solve for x, and you plug it back into these two, they would add up to 180.
So what are we finding? X?
Right now, we're just
Correct.
finding x, yeah. So how would you find x from here? We would solve this equation, right? And then we would stop. Okay? We're not gonna solve the equation right now, but that's how we would do it. Okay? We know how to solve equations, we've done that. Okay, we practiced that. But that's how we would do it, okay? Go ahead, Sarah.
You want those skills, do you?
We got here at 2 or?
Two or three? Okay. So, example 27 here, okay? So right below this, we have, right now we have 4 different angle pairs. Four different sets of angles we're talking about. We have 4 and 5, these two down here, 4 and 3, 2 and 4, and 1 and 5, okay? We're asked to classify whether it's a linear pair, vertical angles, or neither, okay? We're asked to classify whether it's a linear pair, vertical angles, or neither. How many categories do you see right here? 3, okay? How many questions do we have? 4, so we're gonna use each one once, and how many times we're gonna use one of them? Twice, okay? You're gonna use each one of these at least once, one of them gets used twice, okay? So, if we look at angle 4 and angle 5, I would ask you, don't flirt, I would ask you, is that a linear pair? Is that a pair of vertical angles? Or is it neither, okay? That's what I would ask you, okay? I want you guys to try doing A, B, C, and D on your own right now, okay? Like I said, you'll use each one once and one of them twice. Once you finish or have questions on A, B, C, and D with this example, I want you to raise your hand, okay? Once you finish or have questions, I want you to raise your hand, okay? Got it, please stop messing with the glasses.
Can I go to the next one?
Ian, would you start? Stop.
Are they next to each other? Are they adjacent? Are they next to each other?
Hard today, Ian. You're really trying to pass this class without the show.
Hi. From Peter. That's an old son.
Oh, let's say.
So you're about to say really?
Are they right next to each other? Was there any between? Why? So if you look at 4 and 3.
Can I please just give you Tylenol before it's last 2 minutes? My head hurts and I want to go away from my day.
There's X factors.
People get out of the room at the same time.
I'm probably gonna be.
And you see a perfect X. Yeah.
I can't go home. Let's start.
Make that hard call now instead of.
Go home. Go home and bang Dongo.
No, I'm
That's
just,
great
I'm
on
the one
me.
that's an expert.
Bang your Dongo.
I'm sorry.
Wait. Let's talk about this one up here, guys. Let's talk about this one up here. Okay? Jessica, what do you have for letter A? Equals 4 and equal 5. Linear pair. Very good, okay? Boys, stop, guys. Okay, so angle 4 and angle 5, they add up to make a straight line, okay? They're adjacent. They share this vertex in the side, and they make that one straight line 180 degrees. It's a linear pair, okay? Taylor, what do you have for letter B? 4 and 3. Yes.
I put vertical, but you said that mine was right.
Did you? Oh, I'm sorry about that. Then I must have checked.
Yeah, you should be sorry.
Okay. Your arm's gonna be sore for your
I
day
just
today.
did.
On all the shade. Okay. Taylor, what do you have for letter B? Vertical angles. I agree. Okay. Hey, one question I was asked, and I want to highlight this because I think it was a really good question. I want everyone to hear. Okay. Was, hey, I thought they had to make this perfect X though. Right now, this doesn't seem like it makes an X. Okay. If I cover that up and we pretend that it actually covers it up, it doesn't just project on top of it. Do we now have a perfect X? We now would have a perfect X. Okay. So this angle 4 and 3, we have a perfect X surrounding that. And that's what matters for them to be a vertical angle there, okay? Letter C there. Sam, what'd you have? Okay. I'm gonna disagree because these don't make an exact X. So that's an X here, but doesn't quite make an X there, okay? Anybody tell me what it would be then if it's not vertical, okay? Casey, what do you think? Yeah, I agree. I think it would be neither, okay? It's not quite a linear pair either. Boys' offside conversation's done. Okay, wouldn't quite be a linear pair either because angle 1 is between these two angles, okay? They have to be right next to each other for that, okay? And then letter D, what you have there, Jillian? Okay? You didn't do it? Okay. Colin, what did you have? Okay, neither. I would agree it's neither, okay? It's not quite a pair of vertical angles because they don't make that X, okay? And it's not they're not adjacent. There's an angle between them, so they can't be a linear pair either, okay? Question on any of those 4. Okay, going right below this, okay? Hey, I want to talk about, first with these supplementary angles. Sorry for the, A and LS being weird. I'm not sure what happened there, okay? For the supplementary angles, we said they add up to what?
180.
180 degrees, okay? Add to 180 degrees, okay? What about complementary angles? What do you think? They're going to add up to 90, okay? They're going to add to 90 degrees. Okay?
What?
That's a new one we just learned. Complementary angles add to 90 degrees. We had already learned a little bit earlier in the lesson, I figured out, okay, that supplementary angles add up to 180. Now we're learning complementary angles add up to 90, okay? Hey, I have this poster over here. It's one of my favorite posters in my room, okay? It's a really punny one, a honey one with a P. Okay? Angle B and angle A, they're complementary angles. They add to 90 degrees. But look at what angle B says to angle A. I like that you're a good friend. Angle A says, I like the way you always help me. They're complementing each other. Get it? I think that's pretty funny. Okay. I like it too.
Mr. Thompson, can I please go do something on my headache? Because it's been over 10 minutes and the girl's gone and I feel like I'm sick. It's really just
Alright. We're gonna skip over the picture part for now. Okay? I do. Hey, so on this last page here, okay, we know how to solve one like this. We've been doing those for yesterday, or last class and today. Okay, we're gonna skip over example A. Okay, we're gonna skip over example A then. I do want to go to example B here. If we're told that in the red here, this is angle of 26 degrees, could we figure out one of these other three angles and how? Could we figure out one of those other three angles and how? Okay, Clyde, what are you thinking?
B is 26
Hey, how do we know that?
because it is.
Okay, they're congruent because they are a pair of vertical angles. Okay, they share this vertex, their sides make that x, and they're opposite each other, so they're always going to be congruent. Okay, very good. Okay, could we find either angle A or angle C from this information too? Grace, what are you thinking?
So A is 26 degrees is a straight line, so we can just take 180 minus 26.
Yeah, we're going to take 180 minus 26. Okay, if they add it to a straight line, and they're adjacent, what do we call it? Called a linear pair. Very good. So we know angle A has to be 156 degrees, okay? Can that help us figure out what angle C is?
Aren't they adjacent?
Okay. Aren't what adjacent?
A and C.
A and C, those are congruent. Okay, I think you're mixing up words here. Adjacent is next to. Congruent means they're equal in measure. So I'll put
I
two
thought
arcs.
they meant X. I thought they make an X.
They make an X, okay? So they're vertical angles. Vertical angles make the X, and they're opposite each other and share that vertex. So they are congruent. They're 156 degrees, okay? It is 154, excuse me, jeepers. I even wrote that down there. Thank you for saying something, Colton. And I oops. Okay, 154 degrees. Thank you, good catch there, Colton. Okay, questions on that? Okay, so we use vertical angles, we use linear pairs to figure that out, okay? Let's go right below this, okay?
B.
Hey, on letter C, what kind of pair would this be? What kind of relation do we have there? They are vertical angles, okay? They share the vertex, they're opposite each other, sides make that X, okay? So these angles would be congruent, equal in measure, so we can set them equal, right? Okay, we're gonna stop with that example on this part, okay? And we're gonna move on to example D. I just wanted to highlight how you would set that up, how you would approach that problem, okay? On example D here, we're trying to find X and Y, okay? Well, if we look at X, we have the green and the orange have X, and the blue has the Y, okay? So we might need two separate equations if we're doing two different variables, okay? So we do one equation, solve, stop, that's X. One equation, solve, stop, that's Y. You can go and take that out, please, okay? Who can tell me one of the equations we'd use for either X or Y? One of the equations we would use for either X or Y. Okay, Clyde?
3x minus 5 plus x plus 15 equals 180.
I don't quite agree with that. Okay. What are 3x minus 5 and x plus 15? I love that you took a shot on it, though, okay? What are these? What kind of angles are these? Vertical angles, okay? They make that x there for us, and they're opposite each other, share a vertex. We know vertical angles are always congruent. So what can we do with these?
Plus 3x.
Okay, 3x minus 15 equals what? X plus 15, okay? Or excuse me, I did minus 15. That should be minus 5, shouldn't it?
Okay, yeah, that one makes sense with the one below it, y is
Okay, so these two angles, what kind of relation do we have there? They're adjacent and they add up to 180. They're a linear pair, so can we add them up to 180? Y plus 20 plus 4y minus 15 equals 180, okay?
That does not make sense.
Okay, will they make a straight line?
Oh, okay, never, I was looking at the wrong name.
Okay, good questions, okay?
Right, stop.
Okay, hey, we're done with the notes there for today, okay? We only have one section left, we just have that very back page for next time, okay? So that very back page for next time, okay?
So we have a test soon.
Yeah, so reminder, okay? So next class, which will be Trooper Tie Tuesday, okay? We're gonna do 1.6, our last section, okay? Then, on the following class, we will review, that'll be a week from today, Thursday. And the following class, okay, so 2 Mondays from today, we will be taking your test, okay? So that's how we can have, okay? A week and a half. We'll have two more classes before then. Okay?
Very good.
Okay, real quick, I want to give just a couple pieces of advice on this homework, okay? A couple pieces of clarification, advice, blessing, that after get, okay? So as you get it, please look at the front of it real quick. As you get it, please look at the front of it real quick, just so I can explain something a little more clear for you. Okay? Hey, on number 1 and number 2, even though they use the same diagrams to the right, solve those as completely separate problems, okay? Solve them as completely separate problems, okay? So the measures on number 1 do not affect the measures on number 2 and vice versa, okay? Solve them as completely different problems, okay? And then on number 5, you might have to use one from each picture for a couple of those, okay? You might have to use them from some different pictures on those, okay? Other than that, you don't need a protractor or anything like that, okay? That is my only instructions, okay? Otherwise, hope you guys have a great weekend. Online.
Do you want me?
Hey, Celeste, next time what would be a better alternative than throwing that? What would be a better alternative than What would be a better alternative to throwing that? What about using your feet and walking the road? Legs broken? I bet it looks like it. I'll pray for a quick recovery.